Reducing. Am I audible, Prashant?
Yes, madam.
Am I audible and are you able
Yes,
to see
madam.
the screen?
Yes, madam. Yes, madam.
Okay. So last class we were discussing about reducing the Boolean functions and demorganizing the Boolean functions. Okay, and also some proofs, and also we were discussing about the construction of all the other logic gates using the universal gates and inhibit and enable circuits. Also, we have discussed. Today, our topic is Boolean functions and their representation. Okay, Boolean functions and their representation. Okay, in this itself, we will be covering SOP POS forms and important things in this main topic are SOP and POS form, truth tables, and your standard canonical forms, KMaps. All these things will fall under this category. So, how to represent a Boolean function? Okay. So, in this itself, about K maps, why we have to go K maps is very important topic, and actually how it relates to your hardware. Okay. So, I will tell you that. So, normally to represent any function, let us suppose it may be xy plus xyz something. Okay, so any function, first thing is we can represent any function in SOP form. Form means sum of products. Okay, how do you represent in sum of product form? So this SOP form is also called as disjunctive dis, disjunctive normal form, or we can call it as DNF. Okay, so how do you represent in SOP? Normal SOP form, a function with the literals a b c can be represented as a bar b plus, this is just an example. Okay, so this is sum of these two are the products. Okay, sum of two products, sum of product form. And similarly, if you go for POS is nothing but product of product of sum. Okay, so product of sum, and this is also called as conjunctive normal form. Okay, so CNF, it is also called as CNF. So normally a function with variables a, b, c can be represented as a bar plus b bar into b plus c. Anything, function may be anything. So this is product of, this is a sum and this is a sum. So in between we are using a product of sum. Okay, third one is, so third way of or third method of representing any Boolean function is truth table form. Okay, truth table form. So let us suppose if we have a function a bar b bar plus b bar c. So how do you represent in truth table form? So you will be writing decimal value. Okay, decimal value, and you will be having a b c three variables are there, and this is the function a bar b bar plus b bar c. Okay, so 0 1 2 3 4 5 6 7. Okay, so three literals are there. Okay, 2 power 3 will be equal to 8 0 decimal binary representation 0 0 0 0 0 1 1 0 1 1. Okay, and 0 0 0 1 1 0 1 1, and similarly you can just assume. So depending upon this, we will be computing the function a bar b bar plus b bar c. Okay, depending upon the logic equation, we will be computing the function. What will be this a bar b bar plus b bar c will be equal to 0. So you compute like that. Okay, so this is nothing but truth table form. You know this, just to show you I'm telling. Okay, fourth method of representing a function is standard. See, this sum of product is different. Okay, sum of product form is different, and here the other one is fourth way method of representing is standard standard SOP form. Okay, standard sum of product form. Okay, so this is called as, you should remember, this is disjunctive canonical form. Okay, this is disjunctive canonical form, or we call it as DCF. Okay, also it is called as expanded SOP or canonical SOP form. Okay, expanded SOP, some expanded sum of product or canonical sum of product form. Okay, how do you write this? If I am giving you a function with variables a, b, c, so let us suppose the logic is a bar b plus b bar c. Expanded SOP, how do you write? You need to expand this function a bar b. So here c is missing, c plus c bar. To expand, I need to add. Okay, c plus c bar is nothing but 1. Okay, if you are adding 1, no, nothing will be loosened. Okay, so b bar c, here variable a is missing. So a plus a bar, you need to expand. Your intention is to expand. So you will get a bar. Okay, so a bar bc plus a bar bc bar plus a b bar c plus a bar b bar c. Okay, so here the function is sum of number of product terms. Okay, sum of number of product terms. Okay, so each product term should contain all the variables. Having the variables a, b, c, each contain all the variables, either complemented or in uncomplemented form. Okay, you should remember this one. So whenever we are expanding a function in standard SOP form, the final function should contain all the variables a, b, c, అన్ని variables ఉండాలి, and either in complemented form or complement అయినా ఉండొచ్చు, uncomplement అయినా ఉండొచ్చు. Okay, so here a is in complemented form. Okay, here a is in uncomplemented form, anything. Okay, so but it should be there. Okay, so this is called a standard SOP form. And the fifth one is, okay, let us suppose here one more thing I forgot to tell you. So this is SOP form, right? In this SOP form, so here we call it them as see this these are all the product terms, right? These product terms are called as mean terms. Okay, so these product terms are denoted with they are denoted with M0, M1, M2, okay, till M7, whatever it may be. They are denoted with small, okay, small m suffix 0, 1 like that. And these are called as mean terms, okay. So these are called as mean terms, okay. So let us suppose if we take a 3 variable function, okay. So example, if we are taking a 3 variable function, so if the mean terms can be given as what? So 3 variable function low, how many mean terms will be there? 2 power 3. Okay, 2 power 3 is equal to 8 mean terms will be there. Okay, 8 mean terms will be there. So these 8 mean terms will be M0, M1, M2, M3, M4, M5, M6 and M7. Okay, these are the mean terms. And how to denote these mean terms? So A, B, C are the function variables. Okay, A, B, C are the variables of the function. Okay, so M0 is equal 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Here 0 and 0, 1, 1, 1 and 1. So A, B, C is how do you write the mean terms? M naught will be equal to what? So M naught will be equal to what? A
A
bar,
naught,
B
B
bar,
naught, C
C bar.
naught.
Yes. Okay. So M1 will be equal to A bar, B bar. So here A bar, B, C bar. A bar, B, C. Okay. Similarly, like that. Last then chapandi A, B,
B,
C.
C.
Okay. So this way you represent this mean terms. Now see here. This let us suppose this example I have taken A bar B plus B bar C. We have terms. Okay. So now in terms of a function, now function A, B, C, function with variables A, B, C can be represented in terms of mean terms as what? Which will be equal to what? A bar B C is giving what? A bar B C. What is the value here? 3. Okay.
3.
So, M3 plus next A bar
2.
B C ఏమొస్తుంది
2 madam.
ప్లస్ M2 ప్లస్ తర్వాత A బార్
5.
BC అంటే
5.
5 ప్లస్ A బార్ B బార్ C
1.
M1. Okay. So when chronological order we have to put M1, M2, M5 and M7. Okay. This way this is called a standard SOP form. Okay. So now if I ask you to write this is called F. Okay. So this is a function you are representing in F. This is 7. Sorry. What is this? 1, 5, 2, 5 and 7. Okay. So the your F complement will be equal to what? 0, which are not present here will be your F complement. It will be 0, 3 and 6 will be your అంతేనా 0, 3, 6 ఇంకేమైనా మిస్ అయిందా 4, 0, 3, 4, 6 will be your F complement. Okay. So this is standard what standard SOP form. Okay. So next one is we will see more examples and let me first tell you other types also. Okay. So next we are done with 4. Fifth one is standard POS form. Okay. Standard POS form. Next one is fifth one. Standard POS form. Okay. Standard product of this is called as conjective canonical form. Okay. This is called as conjective canonical form CCF. Okay. So or else you can also call it as expanded POS or canonical POS. You can call it as expanded POS or canonical POS. So example, if we take a function can be represented with function with variables A, B, C can be represented as A bar plus B bar, A plus B. Okay. So this is nothing but product of sum. Okay. Product of sum. Okay, we know that. So this is not normal in POS form. In standard POS form, what you do is the same function with variables A, B, C. You need to expand it. How do you? Here you need to use the distributive law. Okay. So distributive law. So A bar plus b bar plus c complement. Okay, so not, it is 0 anyway. C complement is 0. Just see why only thing in POS form or SOC form, only intention is so final product sorry, final SOP or final POS function what you are getting, that function should contain all the literals. Okay, A B C, all the literals. Okay, so and here A plus B plus, here also C complement if you are using, no problem. Okay, so by distributive law, by using the distributive law, I can write it as A bar plus B bar plus C into A bar plus B bar plus C bar. Okay, so and similarly A plus B plus C here. Okay, I'm applying distribute. I have applied distributive law to this function, and this term, sorry, I am applying distributive law to this term now. A plus B plus C, A plus B plus C bar. Okay, this way. So sum of term. Okay, it contains all the sorry, as it contains each of n variables in either complemented or uncomplemented form. Okay, so this is one term. It is having ABC terms. ABC ఇక్కడ కూడా ఉన్నాయి, ABC ఇక్కడ కూడా ఉన్నాయి, and ABC ఇక్కడ కూడా ఉన్నాయి. So either in complemented or in uncomplemented form. Okay, so here these are called as, okay, so these product terms are called as these are product terms for the max terms. Okay, so they are called as max terms represented with M naught, capital M, M1, M2, M3, and so on. Okay, so here how do you represent a function? F of A, B, C can be represented as product term is represented with pi, and అక్కడ ఏంటిదంటే we'll be using sigma. Some terms sigma తో represent చేస్తాం. Some of product terms of M 0, 4, 6, 7, or else you can represent it with product terms of M naught. What is this? A bar, B bar plus C bar. ఇదేంటి చెప్పండి, క్యాపిటల్ యూజ్ చేయాలి. ఓకే, M0, M4, M6, M7. Okay, so do you want me to write the truth table or is it okay?
Okay, madam.
So next one వచ్చి ఏంటంటే, this is one form and the other one is Venn diagram. Yeah, Subramaniam, you have joined. Very good. Okay, Venn diagram. I am thinking only Prashant is there in the meeting. So Venn diagram form. Venn diagram form though. So for and we know intersection we will be using for and for or we will be union ki or use chestam. Okay. So if function, yeah, or the union use chestam. So like that A, B, and C. Okay, wherever intersection unte or union, you represent it like this Venn diagram form. We need not stress much on this Venn diagram, why? Because nowhere we will be using. Just the thing is you should know. Okay, a function can be represented. Next one is octal design. Octal design ante meeku telusu already. Okay, so a string of zeros and ones is, so I am giving 0 1 1 0 1 0 1 0. Okay, this is a string. Okay, this is a string consisting of zeros and ones. It is called as characteristic vector. Okay, characteristic vector. It is called as characteristic vector. So octal design lo మనం ఏమన్నా ఎలా represent చేయొచ్చు? From M0, M1, M2, okay, M3, M4, M5, M6, M7. Okay, so it's 0 1 1 0 1 0 1 1. Okay, so here what the function with variables A, B, C can be written as what? Once ఎక్కడెక్కడ ఉన్నాయి చెప్పండి నాకు, ఏ పొజిషన్ లో. సో స్టార్టింగ్ ఫ్రమ్ ది రైట్ సైడ్. ఓకే, రైట్ సైడ్ నుండి 0
1
1
3
3
5 6.
6. Okay, So this is called as octal way of representing. Okay, last one వచ్చేసరికి ఏంటి అని అంటే KMap representation. Okay, so story అంతా ఇక్కడే అన్నమాట. So Karnaugh Map. Okay, so KMap. So here what is the use and why do we have to go for KMap?
Madam,
Anyone can tell me? పైన ఉన్న వాటికి అన్నిటికీ డ్రాబ్యాక్స్ ఏంటిది? Why do we need to go for KMap? Yeah.
ఆక్టల్ డిజైన్ లో ఓన్లీ ఎస్ఓపి బామ్ ఆర్ పిఎస్ రెండు యూజ్ చేస్తాం మేడం, ఓన్లీ వన్ టైం.
ఆక్టల్ డిజైన్ లో ఎస్ఓపి పిఓఎస్ ఏముండదు, జస్ట్ రిప్రజెంటేషన్ వేరెవర్ వన్స్ ఆర్ దేర్ యు ఆర్ రిప్రజెంటింగ్ అ ఫంక్షన్ ఎనీవే యూ కెన్ రిప్రజెంట్ ఎస్ఓపి అయినా పిఓఎస్ అయినా ఎనీ ఫార్మ్ యూ కెన్ గో.
ఓకే.
So KMap represent see what are the KMap you might have heard about KMap. Okay, so only thing I'm asking you, uh, what are the drawbacks of the above 7 realizations and why do we need to go for KMap?
పైన అన్ని కూడా ఓన్లీ రిప్రజెంటేషన్ మాత్రం యూజ్ చేస్తాం మేడం, బులియన్ ఎక్స్ప్రెషన్ ని రిప్రజెంట్ చేయడం కోసం. నెక్స్ట్ కేమ్యాప్ వచ్చేసరికి ఎక్స్ప్రెషన్ ని రెడ్యూస్ చేయడం కోసం యూజ్ చేస్తాం.
సో
బులియన్ ఎక్స్ప్రెషన్
ఎక్స్ప్రెషన్ రెడ్యూస్ చేస్తే మనకి అడ్వాంటేజ్ ఏంటి చెప్పండి?
నెంబర్ ఆఫ్ గేట్స్ అనేది తగ్గుతాయి మేడం.
నెంబర్ ఆఫ్ గేట్స్ తగ్గుతాయి. వెరీ గుడ్. నెంబర్ ఆఫ్ గేట్స్ తగ్గితే ఏమవుతుంది చెప్పండి?
సర్క్యూట్ కాంప్లెక్సిటీ కూడా తగ్గిపోతుంది.
సర్క్యూట్ కాంప్లెక్సిటీ తగ్గిపోతుంది. సర్క్యూట్ కాంప్లెక్సిటీ తగ్గిపోతే
ఆటోమేటిక్ కాస్ట్ తగ్గుతుంది, పవర్ డిసిపేషన్ కూడా మనకు తక్కువ ఉంటుంది.
వెరీ గుడ్, వెరీ గుడ్. సర్క్యూట్ కాంప్లెక్సిటీ తగ్గితే ఈజీ టు డిజైన్. ఓకే, హార్డ్వేర్ కాంపోనెంట్స్ తగ్గుతాయి. హార్డ్వేర్ కాంపోనెంట్స్ తగ్గితే ఏరియా తగ్గుతుంది. ఏరియా తగ్గితే తగ్గిపోతాయి. కాబట్టి we will get very 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 simple, handy and less size device. Okay, so compactness of the device. Okay, so very good. Okay, so now we will go for this KMap. Yeah, KMap law. So what once I will show with the help of PPT we will see. You are able to see, right?
ఎస్ మేడం.
See, actually, what is what is the use of KMap is circuit optimization. As you have said, circuit optimization. So, what is the goal to obtain the simplest implementation for any given function? It is more formal approach. Okay, so we can cut down the cost. We can cut down the cost and to measure the simplicity of a circuit. And here cost criteria for distinct cost criteria. Cost ela cut chestaru anante. So three things you need to take care. Three things you can, it can be divided into three things. First thing is literal cost. Okay, literal cost. Literals ante entide. So how many variables are there? They are the literals. Okay, and gate input cost and gate input cost with knots. Okay, so so what is this see, how can we cut down the cost by simplifying the functions using KMaps? KMaps lo literal gate inputs and gate input cost with knots. Okay, so three let us see this three. So literal is nothing but a simple variable or its complement, a or a bar. Okay, a or a bar. What is literal cost? the number of literal appearances in a Boolean expression corresponding to the logic circuits in a diagram. See here, I am giving you an example. So BD, so a function can be represented with BD plus A bar BC plus A C bar D bar, and see the second function and see the third function. So see, if you are I am thinking, if I am simplifying the function, I will get the same function. Okay, so మూడు కలిపి ఏంటిదంటే ఒకటే అవుట్పుట్ ఇస్తాయి నాకు. Okay, for example, these three functions are there. Three functions are giving me the same output. So which one I should take? Which one I should prefer among these three? So first function is having 8 literals. Yes. Second function is having 10 literals. Third function is having, second is having 11 literals, and third function is having 10 literals. Obviously, I will be preferring the first one only. Okay, first one only. Why? Because number of literals is equal to number of transistors. Okay, you should remember this. How many literals are there? If I am going for a CMOS logic, how many literals are there? Number of PMOS circuits and number of NMOS circuits. 8 అనుకోండి, 8 literals అనుకోండి, 8 PMOS transistors, 8 NMOS transistors ఉండాలన్నమాట. Okay, so that is one thing. Number of literals should be less. And second one is gate input cost. Gate, we can cut down the gate input cost also. So what is this gate input cost? The number of inputs to the gates in the implementation corresponding exactly to the given equation or equations. Okay, so if gate inverters are not counted, okay, GN ante inverters counted. Okay, so I'll read it once again. Number of inputs to the gates in the implementation corresponding exactly to the given equation or equations. Okay, so number of gate inputs. So actually మనకి ఎన్ని gate inputs కావాలి? So for if you take for SOP and POS equation, it can be found all literal appearances, number of terms, and optionally number of distinct complemented single literals. Okay, so all these things are calculated when we are talking in terms of gate input cost. So if we see this one, how many any gates? So overall నేను ఏం చెప్పాలనుకుంటున్నానంటే, so see these three functions. ఈ three functions కి మీకు ఎన్ని gates కావాలి? Okay, so now each and every complement is requiring one NOT gate. B bar, C bar, D bar ki 3 NOT gates are required. Okay, so here is 2 AND gates are required here. Okay, function BD 1 AND gate. So here how many 3 AND gates are required here. 3 plus 2 OR gates are required. Okay, so 5, and at the same time how many NOT gates are required? చూడండి, function ki 3 AND gates are required, right? 3 AND gates are required. And 2 OR gates are required. Okay. 3 NOT gates are required. Yeah. So if you see the inputs, how many number of inputs are there?
4 inputs, madam.
4 inputs కాదు చూడండి. So this is 3 input AND gate and this is 3 input AND gate. Okay, 3 input AND gate కి దీనికి 3 inputs ఇస్తున్నారు, దీనికి 3 inputs ఇస్తున్నారు, and 6, totally 8. Okay, totally 8. How many complements are there? 8, 9, 10, 11. అర్థమైందా? ఇక్కడ ఏంటిదనంటే పెన్సిల్ తో రాయడానికి కుదరదు ఇక్కడ.
బట్ అందులో ఇన్వర్టర్ కౌంట్ కాదు అన్నారు కదా మేడం.
ఇన్వర్టర్ కౌంట్ అంటే ఇప్పుడు చూడండి, ఇన్వర్టర్స్ నాట్ కౌంటెడ్, ఇదేమో ఇన్వర్టర్స్ కౌంటెడ్. ఇన్వర్టర్స్ కౌంట్ అవుతే నీకు 14 వస్తుంది, ఇన్వర్టర్స్ కౌంట్ అవ్వకుంటే 11 వస్తుంది. చూడండి ఇన్పుట్స్ చూడండి, BD. ఓకే, సో ఇది 2 input AND gate. what I'm showing here is this is 2 input AND gate. Okay, 2 input AND gate. Identity 3 input AND gate. 2 plus 3 any inputs 5. మళ్ళీ ఇది 3 ఇన్పుట్ AND గేట్. ఓకే, ఎన్ని ఇప్పుడు 5 plus 3 is equal to 8.
8
దీనిలో మళ్ళీ ఇన్వర్టర్స్ ఎన్ని?
3
9, 10, 11. Okay, so when inverters are not counted, it is coming 11 కదా.
yes
One
ma'am.
second. So if the inverters are not counted, it is 8. When inverters are counted, it is equaling to 11. Okay, so out of all, ఇప్పుడు చూడండి, so in these 3 functions, let us suppose ఇదే తీసుకుందాం మనం. gn అనేది తీసుకోవద్దు. Counting the inverters, I am getting 11, 15 and 14. Okay, so out of this I will prefer this logic only. Okay, out of this I will prefer this logic only. Okay, so this is gate input cost. So these 3 gates, 5 gates are there. 5 gates are there. 5 plus 3 not gates equal to total 8 gates are there. 8 gates కి మీరు 8 gates కి మీరు ఇచ్చే ఇన్పుట్స్ ఏంటిదంటే 11 inputs. 11 inputs. Okay, so here in this function, if you are counting the inverters, it will be 15, and here in this function, if you are counting the inverters, it will be 14. So out of all, I will be preferring this function only. ఓకే, ఇక్కడ తప్పిచ్చారు అనుకుంటామా ఒకసారి, ఆర్ ఎల్స్ వాట్ ఐ
కరెక్ట్ అవుతుంది మేడం. ఒకసారి చెప్తాను చూడండి. బీడీకి
చూడండి.
2 ఇన్పుట్స్, నెక్స్ట్ ఏ బి బార్ సికి 3 ఇన్పుట్స్, టోటల్ 5 ఇన్పుట్స్ అయ్యాయి ఇప్పటికి. ప్లస్ అలాగే ఏ సి బార్ డి బార్ కి ఒక 3 ఇన్పుట్స్, సో టోటల్ 8. ప్లస్ ఈ 3 టర్మ్స్ కూడా ఇంకొక ఆర్ గేట్, ఐ మీన్ ఒక ఆర్ గేట్ కి ఇవ్వాలి కాబట్టి, సో ఈ ఒక 3 ఇన్పుట్స్, సో 8 plus 3 11 అవుతాయి.
ఇన్వర్టర్స్ కౌంట్ చేస్తే 14 అవుతాయి. ఎస్, ఓకే, ఇన్వర్టర్స్ కౌంట్ చేస్తే 14 అవుతాయి. వెరీ గుడ్. ఓకే, ఓకే. సో see, out of all, we will prefer this one only. Okay, we will prefer this one only. Why? Because less hardware is the we should cut down the hardware cost. Okay, so that is one thing. And next one is cost criteria. If you see this a plus, see this function, a plus bc plus b bar c bar. Okay, so how many gates are required for this? 2 AND gates I am taking, bc and b bar c bar, and a directly you are feeding. So yes, this is the, so here in this case, gates, if you are not counting the inverters, so the number of inputs, gate inputs will be equal to what? 1, 2, 3, 4,
5, 6, 7.
5, 6, 7. Okay, చూడండి, 1, 2, 3, 4, 5, 6 and 7. Okay, so total, if you are counting the inverters, it will be equal to 9. Okay, it will be equal to 9. So here in this case, so L literal count, it counts the AND inputs and the single literal OR input. G, what is G? G is adds the remaining OR gate inputs, and GN, what it is doing, it is adding the inverter inputs. Okay, ఈ రెండు ఏంటిది అని అంటే, these are the inverter inputs. Okay, so this is one example. And if you take this function f is equal to abc plus a bar b bar c bar, so here number of literals are equal to 6. A should be considered as 1 literal, and a bar also should be considered as 1 literal. Okay, so abc, so total 6 literals. And how many gate inputs are there totally? So these 3, okay, 6 and these 2. Okay, total 8 gate, so total 8 gates inputs are. So these, if you are considering 3 NOT gates, your gate inputs will become 11. Okay, this is one example. Only examples I am showing. If you take this function a plus c bar, b bar plus c, so how many literals are there? A, B, C, and A bar, B bar, C bar. Total literals are 6. And if you are taking the gate without considering inverters, if you are taking the inputs, so 1, 2, 3, and here 4, 5, and 6, 7, 8, 9. Okay, 9 gate inputs ఉన్నాయి. 9 gate inputs. If you are considering the NOT gates, 1, 2, 3. Extra 3 will be added. 9 plus 3 will be equal to 12. Okay. So see here, uh, same function and same literal cost. But first circuit has better gate input count and better gate input count with knots. Okay, you can see the first circuit. Okay, ఇక్కడ ఏంటిదంటే 9 12 9 12 అయిపోయాయి. ఇక్కడ ఏంటిదంటే 8 and 11. Okay, 8 and 11. So I will consider this circuit only. Okay, why? Because at least 10% of area I can save, and at least 10% of the cost I can save. Okay, so this way KMaps are useful to reduce or to minimize the function. We will be using the KMaps, so which cuts the cost. Okay, ultimate goal is cost cutting and also area optimization. Okay, so now we will start with Boolean function optimization. Okay, so minimizing the gate input. 1 second. Okay, just give me 1 minute time. Just convert this to PPT.
Yes, madam.
Okay. So see here, the intention is minimizing. So minimizing the gate input cost of a Boolean equation reduces circuit cost. Okay. So we choose gate input cost only. Okay. It is very easy to minimize. So Boolean algebra and graphical techniques, these are the tools to minimize cost criteria values. Okay. So here you can get two questions. When do we stop trying to reduce the cost, and do we know when we have a minimum cost? Okay. సో హియర్ సి కాస్ట్ తగ్గుతుంది అని ఇంకా అలా మినిమైజ్ చేసుకుంటూ కూడా వెళ్ళలేము అనమాట. వై బికాస్ దెర్ ఇస్ అ లిమిట్ ఫర్ ఎనీథింగ్. దట్ ఈస్ వన్ థింగ్. సో do we know when we have a minimum cost? So now treat optimum or near optimum cost function for two level SOP or POS circuits first. Okay, either you can convert to SOP or you can go to POS form, so that you can get the optimized circuit. And next one is, ఫస్ట్ మీరు canonical form కి వెళ్ళండి. SOP POS డైరెక్ట్ KMap కి వెళ్ళొద్దు. దట్ ఈస్ వాట్ ఐ మీన్ టు సే. ఒక ఫంక్షన్ ఇచ్చాను, అది ఎలా మినిమైజ్ చేస్తారు అని అంటే SOP ఆర్ POS ఫామ్ కి వెళ్ళండి. సో లేదు, అదేమంటారు, దీంట్లో ఏంటిది, మీరు ఇంకా ఫర్దర్ ఇంకా మీరు కాస్ట్ కటింగ్ ఆర్ మినిమైజేషన్ చేయాలి అనుకుంటే యూ కెన్ గో ఫర్ KMaps. ఓకే, ఫర్ shortcut. Okay, so what is this KMap? KMap is nothing but it is a collection of squares. Okay, it is a collection of squares. Here each square, it is representing a mean term. Okay, collection of squares is a graphical representation. Linking రావట్లేదు. Okay, let's go ahead. So see here, each square is representing a mean term, and the collection of squares is nothing but a graphical representation of a Boolean function. Okay, so if you have adjacent squares, the different value of one variable. Okay, చూపిస్తేనే అర్థమవుతుంది KMap. So I'll show you. Just we will see some highlights on this. So adjacent squares differ in the value. Okay. So 4 variable KMap ఉంటుంది, 2 variable KMap, 3 variable KMap. Okay. So squares ఉంటాయి కదా, squares లో ఏంటిది, each and every square is representing a different value. Okay. So KMap can be viewed as reorganized version of the truth table, or else it is a particular cube representation. Okay. So that is what. Why do we use K-maps? What is the use of K-maps? Finding the optimum solution, optimum SOP form or POS form. Okay. And also two level and or and circuits. మీకు AOI circuits అని ఉంటాయి. So two level and or and circuits implementation చేయడానికి we will be using the K-maps. Okay. So for functions with small number of variables, we will be using K-maps. So um, visualizing concepts related to manipulating Boolean expressions. And so whatever the output from the KMap which we are giving, obviously it is for motto is for CAD design. Okay, so to simplify the computer, to simplify the program so that the CAD design will be very easy. Okay, so if we just I wanted to show you this one. So Boolean space b bar n, b is equal to 0 and binary value 0 1. So what is this, b square is 0 1 into 0 1, which will be equal to 0 0 0 1 1 0 and 1 1. Okay, so this is what Boolean realization. So Boolean cubes, you can see the relevant Boolean cubes related to K-maps. B par 0 and it will be having only one value. So b par 1 and 0 and 1. So see, it is represented with it is represented with the two dots, and here b power 2. Okay, so which is representing 4 squares. Okay, 4 squares. Here it is nothing but 4 dots. It is represented with 4 corners. Okay, 4 corners. So b 3 variable KMap. Sorry, what is this, b power 3. So it is total 8 cells it is having. So this is Boolean cube, so it is having 8 corners. Okay, this Boolean cube is having 8 corners. Okay, this is 16. Okay, 16 variable KMap. Sorry, 4 variable KMap. So total 16 blocks we will be having. So 3 variable KMap లో మనకి ఎన్ని 8 blocks ఉంటాయి. 2 variable KMap 4 blocks will be there. So here what is this, 4 variable KMap lo, so total 16 corners. Okay, 16 corners a cube will be having, a cube inside a cube. So totally you will be having 16 corners. This is the representation in terms of Boolean. So now if we see the 2 variable KMap, okay, if we see the 2 variable KMap, so here mean term M0, M1, M2 and M3 are the mean terms. Okay, 0, 1, 2 and M3, M2 and M3 are the mean terms. Okay, so here mean term M0 and M1 are adjacent. Okay, adjacent to each other, but the different values. Okay, so here M0 is equal to x is equal to 0, y is equal to 0. Okay, M0, what is the function? This M0 block is representing x bar. Okay, so this 0, x is equal to 0 kada. So x bar, and here y is equal to 0 kabatti y bar. Okay, and similarly M1, okay, adjacent to M1 చూడండి, M1 block కి corresponding ఇక్కడ x is equal to 0 కాబట్టి x bar. Okay, x bar, and ఇక్కడ y corresponding block, what is the value of y here? Y is equal to 1 కాబట్టి y. Okay, so M2, similarly M2, if you see M2 ki x is equal to 1. Okay, x simply you will write, and here corresponding y, what is the value of y here? So y is equal to 0, y bar. And similarly M3, if you see x is equal to 1 and y is equal to 1. Okay, so M3 value is 1 and 1. Okay, x is equal to 1, y is equal to 1, it will be xy. Okay, so M1 and M3 also differ in x variable as well. Finally, if you take M2 and M3, they differ in which variable? They differ in y variable. Okay, so I will tell you once again, m0 and m1, they are differing. Y is differing. m0 m2, if you take, which is differing? X is differing. m2 m3, so here x value is same, y value is differing. m1 m3, so what is y value is same, x value is differing. Okay, so this is two variable KMap. Okay, so if you see the truth table of two variable function, so here we are choosing a, b, c and d as the functions, and set of 0 1 to implement a particular function f of x y. So input values ఏంటి 0 0 0 1 1 0 1 1. These are the binary values. What is the function value? A, b, c, d. Okay, these are the functions. Okay, so a is representing what? A is nothing but a and చెప్పండి x bar y bar. So b is equal to what? B is equal to what?
x bar y,
C,
x y bar,
D.
x y.
Okay. So next one is, if you take, now we'll see an example. So example is, you can see this example, f of x comma y is equal to x. Okay, so see here, function is x. So y is equal to, see, this is y is equal to 0, y is equal to 1, x is equal to 0, x is equal to 1. So here for the function f of x comma y, so you can see the two adjacent cells containing ones can be combined using the minimization theorem. Okay, if the function into the f of x y is equal to x. Okay, so x ఒకటి అని అంటే, so these things are zeros. So what is this? మనము x y bar plus x y, you can minimization theorem, if you are using, it will be equivalent to x. Okay, similarly ఇక్కడ మీకు f of x comma y is equal to y అని ఇచ్చారు అనుకోండి, y అని ఇస్తే మీరు ఎలా రిప్రజెంట్ చేస్తారు చెప్పండి? KMap లో f of xy is equal to x అని అంటే, so you have represented like this. xy bar plus xy. Okay, xy bar plus xy. సో ఇక్కడ ఏం చేస్తారు? x కామన్ గా తీస్తే y ప్లస్ y బార్ వస్తుంది కదా, y ప్లస్ y బార్ ఈజ్ ఈక్వల్ టు 1. నాకు పెన్ రాయట్లేదమ్మా, నిమిషం ఓపెన్ చేస్తాను. కనిపిస్తుందా ఇది వర్క్ స్పేస్?
ఎస్ మేడం.
ఇప్పుడు f of x ఫంక్షన్ it is given as x కదా, సో ఇంటూ వేరియబుల్ KMap మనం తీసుకుంటే what is this? So f is equal to x. Okay, so what is this? 0 0 1, ఇదేంటి 0 1. Okay, so what how do you write? Tell me. Function ఏంటిది? f is equal to x అంతే. Okay, so plus 0 plus 0. Okay, here I am writing, so this is y is equal to 0, y is equal to 1, x is equal to 0, x is equal to 1 కదా. So 1 and 1, 0 and 0. Okay, so నేను ఇలా తీసుకుంటాను ఫంక్షన్. Okay, then this function is representing what? దీన్ని ఎలా రాయొచ్చు చెప్పండి? f is equal to, how can I write? x y bar plus what is this?
xy
xy కదా. Okay, so x into y plus y bar కదా, y plus y bar is equal to what? 1 కదా, into 1, which is equal to x. Okay, so function can be represented with ones like, okay, f of s, f is equal to function x can be represented like this. So similarly నేను ఇప్పుడు f of x comma y is equal to y అని ఇస్తాను. దాన్ని ఎలా రిప్రజెంట్ చేయాలి చెప్పండి?
B and D ప్లేస్ లో 1 వస్తుంది మేడం. A and C ప్లేస్ లో 0 0 వస్తుంది.
ఇక్కడ A and B ప్లేస్ లో
B and D ప్లేస్ మేడం.
ఈక్వల్ టు ఇక్కడ B and
D.
Okay, now here how can I write the expression? Tell me.
X bar Y plus XY by XY.
X y x plus
X bar.
x, which is equal to sorry y into. So like this. So this is what. Next one is if you see the function, if you see this function, so g of x comma y x bar y plus xy bar plus xy. Okay, so this is the function. How do you x bar y and ekkada vastu cheppandi? Where is this x bar y? It is A, B, C, D. Okay, so let us suppose so cheppandi x bar y ante x bar y ikkada. Okay, this is x bar y. Okay, and xy bar ante this is xy bar. Okay, this is xy, this is xy. Okay, so that's it. It is having two pairs of adjacent cells containing ones and can be combined using minimization theorem. Okay, so you can even write it as xy bar plus xy plus x bar y plus xy, which is equal to x plus y. You can write it as like this. Now, three variable KMap, if you see, three variable KMap lo, so what is that? దానిలో ఏంటిది ఈజీగా 0 1 పెట్టేసాం, 1 2 1 2 3 4 or ABCD అట్లా పెట్టుకున్నాం. ఓకే, సో ఆర్ 0 1 2 3 we have kept. 3 వేరియబుల్ KMap లో ఏంటిదంటే 3 వేరియబుల్ అంటే ఏంటి 2 power 3. So how many blocks will be there? 8 blocks will be there. Okay, so 8 blocks will be there. So in this 8 blocks x, okay, so column కి వచ్చేసరికి x, row కి వచ్చేసరికి yz. Okay, we are taking, so yz place లో you see this 0 0 0 1 1 0 1 1. Okay, so 1 1 1 0 రాయొద్దు, 0 0 0 1 1 0 1 1. This is investigation. Okay, so if we follow this only we will get the output. Okay, this is a standard form. 0 0 0 1 ikkada 1 0 and 1 1. Okay, 0 1 2 3, and you see the values. Okay, if you see the product terms చూడండి. So m0 m1 m2 and m3, and here m4 m5 m6 and m7. Okay, so there is a small change here. You should observe this, where each min term corresponding to the product terms. So here what is this? X is equal to 0 kada, so x bar y bar z bar. So this is what చూడండి, x bar y bar z. Okay, and here x bar y and z, and here x is equal to 0 on the కాబట్టి blocks అన్నిట్లో x bar వస్తుంది, and yz bar corresponding to this value yz bar. And here also here in this block x is equal to 1, so all these 4 blocks you will get x only. Okay, x only. So corresponding y bar z yz value, corresponding values you have to take. Okay, so y bar z bar x y bar z x y z x y z bar. Okay, so here you should note that if the binary value for an index differs, it is 1 bit position. Okay, The mean terms are the adjacent on the KMap. So this is 3-variable KMap. So alternative labeling you can go for is map use. This map use, it largely involves entering values into the map and reading of the product terms of the map. So alternating labelings are also useful. Okay, 0, 1, 2, 3, 4, 5, 6, 7 or X, and ఇక్కడ మీరు పెట్టుకోవచ్చు ఇక్కడ y, this is 0, 1 it is representing y bar, and here this it is representing y. Okay, this is z, and here z bar, and 4 and 6 are representing z bar. Okay, 0 and 1 are representing y bar, 3 and 2 representing y. Okay, 5 and 7 representing z, and 4 and 6 are representing z bar. Okay, this is alternating labeling. Or else you can see this is x. Okay, so you have 0, 0, 0, 1, 1, 1 and 1, 0. Okay, this is y. So anyways, okay, you can label it anyway. Okay, you will get the same value. Example, if we take the example, so f of x, y, z. Okay, so this is sum of sigma is representing what? Sum of sigma is
products, min
uh,
terms.
yeah. Okay, so 2, 3 and 6, 7 are the mean terms are given. Okay, 2, 3, 6, 7. So here we have 2, 3, 6, 7. So if we are writing the equation, applying the minimization theorem, so what is this? You can see x bar చూడండి, దీనికి what ఈ 1 కి చూడండి. So it is x bar yz. Okay, so the corresponding equation for this one is what? The corresponding equation for this one is what? X bar ఈ 1 కి చెప్పండి just.
X bar yz.
X bar
yz bar man 10 వస్తుంది.
yes, ఇక్కడ సో నేను నోట్ ప్యాడ్ లో తీసుకోండి.
xyz.
xyz. Okay, so if you are minimizing, ఒక్క నిమిషం, 1 second. The same thing I will write in a notepad. Sigma m 2, 3, 6, 7. Two, 3, 6 and 7. Okay, this is 4-variable KMap. So x and yz. Here x is equal to 0, x is equal to 1. Okay, so ఇక్కడ ఏమొస్తాయి చెప్పండి మనకి? 0, 0, 0, 1. ఇక్కడ ఏమొస్తుంది? 1, 1. Okay, so this 0, 1, 2, 3. తర్వాత
4,
4, 5,
7, 6.
7. Okay, 2, 3, 6, 7 మనకి ఇక్కడ వస్తున్నాయి కదా. 2, 3, 6 and 7. Okay, so దీనికి కరెస్పాండింగ్ ఈక్వేషన్ చెప్పండి ఏమొస్తుంది? x bar y z, అంతేనా?
Yes ma'am.
Plus for this corresponding you tell me x bar
y z bar
plus for this
xyz.
For this
xyz bar.
xyz bar. So we'll try to minimize this. Minimize చేద్దామా? Okay, so what is ఎలా రాయొచ్చు చెప్పండి? x bar కామన్ తీసి, shall I take x bar common? You tell me, how do we minimize?
First two terms లో x bar y కామన్ తీసాం.
x bar y కామన్ తీసి z plus z bar. Okay, plus second two terms లో ఏం కామన్ తీసాం? x z plus z bar. Okay, So this will be equal to 1 x bar y plus xy. Okay. So which will be equal to what? Y commonly see x plus x bar, which will be equal to 1. Okay. Minimize item. So this way. Okay. Next one. Okay. So next. Now combining, this is one example. Now combining squares. Okay. So by combining the squares, we can reduce the number of literals in a product term. We will see that combining the squares. So we will reduce the literals in the product term, and if you are reducing the literals in the product term, literal cost will be reduced. Okay. So other two cost criteria are there, right? Gate inputs. Okay. So those cost criteria also will be reduced if you are reducing the literal term. So on a three variable KMap, if you are taking a three variable KMap, three variable KMap lo any 8 squares వస్తాయి. Okay, one square is representing a mean term with three variables. Two adjacent squares represent a cube that is a product term with two variables. Four adjacent terms represent a cube that is a product term with one variable. Eight adjacent terms is the function of all ones. It is called as tautology. Okay, f complement is equal to 1. Okay, so here if you see example 1, example functions. So in this we represent mean terms by mean terms of f by 1 in the map. Leave the mean terms of blank. So if see the example, it is given 2 3 4 5. Okay, so f of x y z is equal to x bar y plus x y bar. 2 3 4 5 చూడండి, 2 3 and 4 5. So 2 3 4 5, how do you write ikkada మీరు, what is this, how can you write this function?
X bar
Hmm.
yz
Hmm.
plus x bar yz bar.
Hmm. ఇక్కడ ఏంటిదనంటే సి సింప్లీ యూ విల్ గెట్ ఎక్స్ బార్ వై ప్లస్ ఎక్స్ వై బార్ వస్తుంది. ఎందుకు అని అంటే, సో ఈవెన్ దో యూ ఇఫ్ యు ఆర్ రైటింగ్ ఇన్ టర్మ్స్ ఆఫ్ సెట్, సో మీరు అది ఎక్స్పాండ్ చేసినప్పుడు, సారీ మినిమైజ్ చేసినప్పుడు ఏమవుతుంది అని అంటే, ఫైనల్లీ ద ఈక్వేషన్, యా కామన్ టర్మ్ విల్ బి దట్ ద ఈక్వేషన్ విల్ బికమ్ ఎక్స్ బార్ వై ప్లస్ ఎక్స్ వై బార్. ఓకే, సింప్లీ మీరు ఇంకోటి ఏంటిదనంటే అది కంప్లీట్ గా ఈక్వేషన్ రాసి మినిమైజ్ చేయకుండా, సో ఈ కేమ్యాప్ లోనే యూ కెన్ simply what you can do is you can combine the squares like this. Okay, you can combine the squares. Okay, so this is here it is representing y. Okay, so you are combining these two squares, it is nothing but it is representing z. Okay, so that is what ఈ two squares మీరు combine చేసినప్పుడు this is representing y. 5 7. Okay, 5 7, these squares if you are combining, it is becoming z. Okay, let us suppose if we take one more example, 3 4 and 6 7. 3 4 6 7, how do you write the equation? Actually మీరు మొత్తము అదేమంటే, if you write the logic equation and if you are minimizing, you will get the same value. Why? Because common terms you will be taking it out. But in this case if you see 3 7 4 and 6, so see 4 and 6 is representing what? 4 and 6 is representing what? See 3 and 7 ఉన్నాయి కదా, 3 and 7 is representing 3 and 7. ఇక్కడ చూడండి, this way yeah, you can write it as yz. Okay, yz. Okay, so yz ఎందుకు అని అంటే ఇక్కడ మీరు x bar it will be equal to 0. Okay, yz. And similarly 6 and 4 ఈ రెండు తీసుకుంటే ఏమొస్తుంది? x 4 and 6 is representing z bar. Okay, 5 and 7 is representing z. 4 and 6 is representing z bar. Okay, so x z bar. ఇలాంటివి చూద్దాం రేపు. Okay, so we will see few more examples. Okay, so simple thing is, okay, you just go through what I explained you today. Okay, so we will have the class tomorrow. If you have any doubts, you can ask me. తర్వాత రేపు 3 వేరియబుల్ KMaps తర్వాత కొన్ని ఎగ్జాంపుల్స్ 16 వేరియబుల్ KMaps ఇవి చూద్దాము. ఇంప్లిమెంటింగ్ డిఫరెంట్ ఫంక్షన్స్ విత్ దిస్ KMaps. What is that? Adders, decoders, all these implementations we will see.
ఓకే మేడం.
ఓకేనా? యూ కెన్ లీవ్.
మేడం ఆన్సర్స్ చూసారా మేడం?
చూసానమ్మా, ప్రశాంత్ నేను చూసాను, ఇంకా నాకు ఇంకెవరిది రాలేదు.
ఓకే.
ఇది తొందరగా కంప్లీట్ చేసేస్తే మనకి తర్వాత we will go to Verilog. యాక్చువల్గా ఏంటిదనంటే ఇది ప్యారలల్గా ఇంప్లిమెంట్ చేస్తూ ప్రోగ్రామింగ్ రాసుకోవడం బాగానే ఉంటుంది. బట్ ద థింగ్ ఇస్ మీకు వెరిలాగ్ కూడా బేసిక్స్ నుండి ఎక్స్ప్లెయిన్ చేయాలి కదా.
ఐ థింక్ అశోక్ అండ్ వాళ్ళకి కావాలి మేడం.
ఓకే, ప్రశాంత్ ఆల్రెడీ ఎస్విలో ఉన్నావు కదా సిస్టమ్ వెరిలాగ్.
నేను అండ్ సుబ్రహ్మణ్యం కూడా మేడం.
ఓకే,
నేను కూడా.
యాక్చువల్గా ఇది ఏంటిదంటే ఫ్రెష్ బ్యాచ్ కింద, అంటే స్టార్టింగ్ డిజిటల్, తర్వాత వెరిలాగ్, తర్వాత ఎస్వి ఐఎమ్ నాట్ కన్సర్న్ అబౌట్